problem based on conduction of heat. Two bodies are connected by a conducting rod, and the bodies are having different masses and they are having different specific heats. This body is at a higher temperature than the other body. Since this is at a greater temperature, this body is losing heat because heat passes through the rod from this body to the other body. As a result, this body is losing heat, and because of that the temperature of this body is dropping, while at the same time the other body is receiving heat, and because of that temperature of this body is increasing. At some instant t second after the start, the temperature of this body has dropped to T2 dash and temperature of this body has gone up to T1 dash. So if we consider the temperature difference between these two bodies, initially the temperature difference was T2 minus T1, but t second after the start the temperature difference has changed to T2 dash minus T1 dash. So temperature difference between the two bodies is changing with time, and the problem tells us to find the temperature difference as a function of time. So to find del T as a function of time, I have written the value of temperature difference at the starting instant. At the starting instant it is T2 minus T1, and the second after the start the temperature difference is T2 dash minus T1 dash. So temperature difference is a variable, so we will have to use calculus approach. We will consider a small time dt after t. In that small time dt, temperature of this body, it has dropped by D2 dash, and the temperature of the other body has gone up by DT1 dash. Okay, because of this change, the temperature difference will also change. What will be the temperature difference due to this change? We know del T dash equal to T2 dash minus T1 dash, or d del T dash. Del T dash is temperature difference and d del T dash is small change in temperature difference. This is equal to d T2 dash minus d T1 dash. So in order to find del T as a function of time, we have to get our d2 dash and dt1 dash. That means drop in temperature of this body and rise in temperature of the other body. In order to get the drop in temperature of this body, we must know how much heat has flown out of this body, and in order to get the rising temperature of this body, we must know how much heat has entered into this body in dt second, because these are the changes in temperature in dt second. So let in dt second dq amount of heat has gone from the body at higher temperature to the body at lower temperature. What is the rate of change of heat? That means rate of conduction at the instant t. Rate of conduction at the instant t is given by this expression K into A into temperature difference. Since this is the rate of conduction at the instant t, we will have to use the temperature difference at the instant t. What is the temperature difference at the instant t? Temperature difference at the instant t is del T dash divided by L. Okay, so dq we'll have to get, as I have already told you, that you'll have to get d2 dash and dt1 dash. We'll get d2 dash and dt1 dash by writing another expression, and that expression will come out of this expression. Or dq equal to k into a into del t dash by L into dt. Okay. Now, considering this body, we'll write dq as m2 into s2 into dt2 dash. Now here, one point regarding the sign is very important. See, dq is positive. dq is some amount of heat that has passed through this body. So dq is positive, some heat has gone out, and therefore m2 into s2 d2 dash dt2 dash, final temperature is less than initial temperature, and we know that final minus initial is dt2 dash. So we'll use a minus sign ahead of this to make it positive, because dt2 dash is negative, we'll make it positive. And for the other body, it will be m1 into s1 into dt1 dash. This will remain positive, will not change this sign, because for this body final temperature is greater than initial temperature. As a result, this change in temperature is positive. I'll illustrate this with the help of a numerical example. For example, suppose this body is having a temperature 50 degrees centigrade and this body is having a temperature 30 degrees centigrade. This is the temperature situation at the instant t. Then in a small time, temperature of this body drops to 48 degrees centigrade and temperature of this body rises to 33 degrees centigrade. If you now calculate the change in temperature for this body, that means we are calculating d2 dash, then it will come out to be 48 minus 50, it will be minus 2. While you are calculating the temperature difference for the other body, we will write it as 33 minus 30 and it will be 3. So d2 dash is inherently negative, and I have used a minus sign to make it positive. So this has a positive value, this has a positive value, and this is positive. This is equal to k into a del t dash by L into dt. Sign is extremely important because in this problem sign creates lot of confusion. So let us discuss it once again. K A del T dash is the temperature difference. This is positive. dt is also positive. That means this expression has positive value. This expression has positive value, and I have used a negative sign to make it positive. Okay, so this is positive, this is positive, this is positive. There is no confusion or doubt regarding sign. From this expression, we'll find dt2 dash and we'll put it here, and we'll find dt1 dash and we'll put it here. Okay, so we'll go back to this and we'll complete this. dt2 dash, it will be written as k a del t dash by m2 s2 l dt minus dt1 dash, it will be written as k a del t dash by m1 s1 l into dt. Okay, so now identify the variable. We have del t dash here, del t dash here, and t is the other variable. So del t dash is one variable, t is the other variable. Or now I am segregating the variables, arranging the variables so that I can do the integration. d del t dash by del t dash equal to minus Ka by L del T dash Ka by L 1 by M2S2 plus 1 by M1S1 dt. Now let us study the negative sign once again. Del T dash is the change in temperature as more and more heat flows from one body to the other body, the temperature difference gradually decreases. So that's why this negative sign, that as time increases, the temperature, as time increases, temperature difference decreases. That's why we have this negative sign. Okay, so I will now go for integration. Let us understand the limit. Time increases from 0 to t, and the temperature difference corresponding to initial time, it was T2 minus T1, initial temperature difference, initial value of del T dash, T2 minus T1, and final value of del T dash, it will be del T. We'll have to find del T as a function of time. We have to find del T as a function of time. Exponential, we have it e in the base, or del T by T2 minus T1 e to the power minus K by L into T, or del T equal to T2 minus T1 e to the power minus K by L to the whole thing